Artificial intelligence, AI, has emerged as one of the most transformative technologies of the 21st century, driving innovations across healthcare, finance, education, transportation, and more. Within AI, two terms often arise: machine learning and deep learning. While these are sometimes used interchangeably, they represent different approaches and capabilities in the realm of intelligent systems. Understanding what deep learning is, how it functions, and how it differs from machine learning is essential for anyone interested in modern AI technologies. Machine learning, ML, is a subset of artificial intelligence that gives computers the ability to learn from data and improve their performance over time without being explicitly programmed. At its core, machine learning focuses on developing algorithms that can identify patterns, make decisions, and improve with experience. Machine learning involves feeding large amounts of data into algorithms that learn to make predictions or decisions based on the data. The process generally follows these steps: data collection, gathering relevant data that reflects the task at hand; data preparation, cleaning and transforming data into a usable format; model training, applying an algorithm to the data to learn patterns; model evaluation, testing the model on unseen data to measure its accuracy; deployment, using the model in real-world scenarios. Common machine learning algorithms include linear regression, logistic regression, decision trees, support vector machines, k-nearest neighbors, and random forests. These models are relatively simple and work well for structured data and well-defined problems. Deep learning is a specialized branch of machine learning that uses artificial neural networks with many layers, hence the term deep, to analyze various types of data. These models are capable of automatically learning hierarchical representations from raw input, eliminating the need for manual feature engineering. At the heart of deep learning are neural networks, which are inspired by the structure and function of the human brain. A neural network consists of interconnected nodes, neurons, organized into layers. Input layer receives the raw data. Hidden layers perform mathematical transformations and extract features. Output layer provides the final prediction or classification. Each connection between neurons has a weight that is adjusted during training to minimize the error in predictions, a process known as backpropagation. Different types of deep learning architectures are used depending on the task. Convolutional neural networks, CNNs, ideal for image recognition and processing. Recurrent neural networks, RNNs, used for sequential data like time series and natural language. Generative adversarial networks, GANs, learn to generate new data that resembles the training data. Transformers now dominate the field of natural language processing, e.g., GPT, BERT. While deep learning is a subset of machine learning, there are several fundamental differences between the two. Machine learning requires manual feature extraction. Human experts must identify the most relevant features for a model to learn effectively. Deep learning automatically learns features from raw data, reducing the need for human intervention. Machine learning performs well on small to medium-sized data sets. Deep learning requires vast amounts of data to perform effectively. Its performance often scales with the amount of data provided. Machine learning can run on standard CPUs with minimal resources. Deep learning requires powerful GPUs or specialized hardware due to its high computational needs. Machine learning is typically faster to train and easier to interpret. Deep learning requires longer training times due to complex architectures and large datasets. Machine learning models like decision trees and linear regression offer greater transparency. Deep learning is often considered a black box, making it harder to understand how decisions are made. Machine learning is embedded in countless technologies we use daily. Here are a few examples. Email providers use machine learning models to identify and filter spam messages. Financial institutions use ML to assess the creditworthiness of borrowers based on transaction history, employment status, and more. E-commerce platforms like Amazon use machine learning to analyze user behavior and recommend products. Manufacturers use ML to predict equipment failure and schedule proactive maintenance. Deep learning has revolutionized tasks that were previously considered too complex for machines. Used in facial recognition, medical imaging, and autonomous vehicles. Deep learning powers voice assistants like Siri, Alexa, and tools like Google Translate. Systems can now transcribe spoken language into text with high accuracy. Deep learning allows cars to detect pedestrians, read traffic signs, and make real-time decisions. Tools like ChatGPT, DALL-E, and Deepfake use deep learning to generate human-like text, images, and videos. Machine learning has advantages such as faster training, easier to understand and interpret, and effective with smaller data sets. However, it is limited in handling unstructured data and requires manual feature engineering. Deep learning has advantages like automatically learning complex patterns, excelling with unstructured data, images, audio, text, and outperforming ML in tasks like image and speech recognition. However, it needs massive data sets, is computationally intensive, and is difficult to interpret.